Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the previous sessions, we talked about floating point representation of a number and error propagation. Also, various methods to solve algebraic and transcendental equations were discussed along with the comparison and error estimation. Examples were also worked out in each method to understand the concept further. Continuing with that style, in this session we are going to solve a linear system of equations. So, a linear system of equations will be solved by direct and indirect methods. So, the objective of this session is to solve a linear system of equations. Direct methods like Gauss-Elimination and indirect methods, Gauss-Seidel method were discussed and examples were worked out in this method. Basically, what is a linear system of equations? It is an equations of n unknowns. For example, you take the first equation as a11x1 plus a12x2 plus etc. a1nxn is equal to b1. This is the first equation, and second equation is a21x1 plus a22x2 plus etc. a2nxn is equal to bn. Likewise, there are n equations an1x1 plus an2x2 plus etc. a(n)(n)xn is equal to bn. Okay. So, this is the linear system of equations, and this particular system of equations, if it is represented in the matrix form and then solved, it is called direct method, and if it is solved one by one, for example, solve the first equation and you get one answer in terms of n minus 1 unknowns, and then substitute the solution got by solving the first equation, the second iteration. Likewise, if you substitute directly the values, then it is called indirect method. Gauss-Elimination method is called direct method, and indirect method, Gauss-Seidel method, is called indirect method and is called iterative method. Gauss-Elimination method. This is the elementary elimination method, and it reduces the system of equations to an equivalent upper triangular system which can be solved by back substitution. Okay. For example, let the given system of equations that we have represented here, the equations, and this is represented as Ax is equal to b. A is the coefficient matrix a11 to a1n and etc. an1 to ann, and x is n unknowns etc. xn, and b is the right hand side elements. For example, instead of having n unknowns, let us take the 3 unknowns only, that is x, y and z. Okay, and restrict your equations to 3 unknowns. That is, let the given system of equation be Ax is equal to b, that is a11x plus a12y plus a13z is equal to b1, and a21x plus a22y plus a23z is equal to b2, a31x plus a32y plus a33z is equal to b3. So, this is a linear system of equations in 3 equations in 3 unknowns, where a11, a12, a13, this is an it's called a coefficient matrix, and this is the unknown matrix. X is unknown matrix and B is the right hand side matrix, column matrix. Okay. Then the first step is you have to write the two matrices together, that is coefficient matrix and right hand side matrix written together is called augmented matrix A comma B. Make A21 and A31 to 0 by row operation only with R1, that is we have to make A21 as 0 and A31 as 0. So, we have to do the operations with row 1 only and make these two elements as 0, and this particular row is called row 1 and this is row 2 and this is row 3. Okay. So, what happens when A21 and A31 is made 0 by the row operation and make A32 as 0 by row operations with row 2 only, so that the second row element is not disturbed. Okay. So, then a upper triangular matrix is formed. Write back the equations and solve for x, y, z. And one more thing is this method will fail if one of the pivots, that is A11, A22 or A33 vanishes. That is, if any of the diagonal element is 0, then we cannot proceed further. In such case, the method can be modified by rearranging the rows so that the pivot element is non-zero. So, this procedure is called partial pivoting and can be easily implemented on computer also, but this is impossible if the matrix is singular. Okay. If the matrix is singular, we would say the equations doesn't have a solution. In particular, the number of non-zero diagonal elements will represent the rank of the original matrix and it will give us a number of non-zero solutions for x, y and z of the linear system of equations considered. Now, instead of eliminating x2 only in the third equation, we would have eliminated it from the first equation also at the end of the second stage, and the augmented matrix becomes A11, that is after making A21 and A31 as 0, this is the matrix remaining. So, A11 dash 0, A12 dash 0, B1, the augmented matrix becomes like this: 0, A22 dash, A23 dash and B2 dash, 0, 0, A33 dash and B3 double dash. This from which we would have the equals of x1, x2, x3 obtained directly without a further computation. That is, instead of using the back substitution, if you write back the equations at this stage, we can directly obtain the values of x, z and then y and then x. And this method is called the Gauss-Jordan method, and both the methods are efficient numerical procedures and can be implemented on high speed digital computers also. Now, the procedure is explained with this example. Solve the following system of equations by Gauss-Elimination method: x plus 3y plus 3z is equal to 16, x plus 4y plus 3z is equal to 18 and x plus 3y plus 4z is equal to 19. Okay. The solution starts like write the augmented matrix. Before that, write the equations in the matrix form. First of all, the given system of equations is written in the matrix form as 1 3 3 1 4 3, then 1 3 4 into x, y, z is equal to 16, 18, 19. Okay. This is Ax is equal to B. Then write down the augmented matrix. The augmented matrix is 1 3 3 16, 1 4 3 18, 1 3 4 19 is the augmented matrix A comma B. Now, we have to do the operations with row 1 and make these two elements which are rounded here as 0. Okay. So, the operations are row 2 minus row 1 and row 3 minus row 1. For doing these operations, just write down the two rows and subtract it. Okay. So, what is row 2? Row 2 is 1 4 3 18 and row 1 is this is row 2, and row 1 is 1 3 3 16. So row 2 minus row 1 is 0 1 0 2, and this is written here 0 1 0 2. Okay. Similarly, row 3 is row 3 minus row 1. Okay. After we obtain this matrix 1 3 3 16 0 1 0 2 0 0 1 3, we can see row 3 minus row 1, automatically this element is becoming 0, and therefore this has become an upper triangular matrix. You can see this has become an upper triangular matrix. So we can solve the system of equations directly from this. The matrix has 1 3 3 16 0 1 0 2 0 0 1 3. Okay. This is the augmented matrix of the first, after the first operation. Actually we are supposed to make this element 0, but already it is 0, therefore we stop the procedure, and this has become an upper triangular matrix, and we write back the equations. The equation is x plus 3y plus 3z is equal to 16, and the second equation is y plus 0z is equal to 2, and the last equation is z is equal to 3. So that we get z is equal to 3, y is equal to 2, and substituted in x plus 3 into 2 plus 3 into 3 is equal to 16. We get x value is equal to 1. Okay. Hence the solution is x is equal to 1, y is equal to 2, and z is equal to 3. Next example is finding the inverse of a matrix given using the Gauss-Jordan method. Gauss-Jordan method is actually slight modification of Gauss-Elimination method. Okay. In Gauss-Elimination method, we are making the matrix as upper triangular matrix, whereas in Gauss-Jordan method, we are making the matrix as a diagonal matrix, so that the values of x, y, z can be directly found without back substitution. When inverse of a matrix is concerned, we will write down A and I, the augmented matrix, as the given matrix A and the identity matrix I, because we are going to do the operations in A, and the I will automatically become your A inverse. Okay. So A, the matrix A is going to become identity matrix, and the identity matrix will automatically turn into A inverse. This is based on the concept as A inverse is equal to I. When you are doing the row operations, A is going to become I, in the sense I is going to become A inverse. So write down the augmented matrix A comma I, the given matrix 1 1 3 1 3 minus 3 minus 2 minus 4 minus 4, and the identity matrix for a 3 cross 3 matrix 1 0 0 0 1 0 0 0 1. Okay. So according to our operations, first of all you have to make this 1 and minus 2 as 0. By the row operations, row 2 is equivalent to row 2 minus row 1, and new R3 is equivalent to R3 plus 2 times R1. Okay. What is happening when you do row 2 is equivalent to row 2 minus row 1. Literally write down row 2. Row 2 is 1 3 minus 3 and 0 1 0, and row 1 is 1 1 3 1 0 0. So R2 minus R1 is 0 2 minus 6 minus 1 1 0. Okay. And then our next operation is R3 is equivalent to R3 plus 2 times R1. What is R3? R3 is minus 2 minus 4 minus 4 0 0 1, and 2 times R1 is 2 times R1 is 2 2 6 2 0 0. Then just add. When you add, it's 0 minus 2 2 2 0 1. Okay. Substitute this in the equations, we get new R2 is 0 2 minus 6 minus 1 1 0. You can see now the identity matrix is no more the identity 1. Okay. And the third row becomes 0 minus 2 2 2, 0, 1. Now, after that we have to make this minus 2 as 0. Minus 2 should be made 0 only doing the operations with row 2. You can see 2 and minus 2, when you add it becomes 0. You just see only these two elements and do the whatever the required row operations. Minus 2 plus 2 has to be added so that we get a 0 here. So, row 3 is equivalent to row 3 plus row 2. So, what is row 3? Row 3 is 0 minus 2, 2, 2, 0, 1, and row 2 is 0, 2, minus 6, minus 1, 1, 0. Then row 3 plus row 2 is 0, 0, minus 4, 1, 1, 1. Isn't it? That is written here. 0, 0, minus 4, 1, 1, 1. Okay. Now, we have made the matrix as upper triangular matrix. The next thing is you have to make this 1, 0, and then you have to make this minus 6 and 3 as 0. First of all, what we have to do is just make this minus 6 and 3 0 with minus 4 by doing the operations only with row 3. So, let me first of all finish off this. New row 1 is equivalent to 4 R1 plus 3 R3. What is 4 times R1? 4 times R1 is 4, 4, 12, 4, 0, 0, and 3 times R3 is 0, 0, minus 12, 3, 3, 3. Just adding 4, 4, 0, 7, 3, 3. Okay. And similarly, minus 6 is made 0. Just look at the matrix again. We have to make this minus 6 as 0. So, 4 times R2 and 6 times R3, right? 4 times R2 minus 6 times R3. Now, what is 4 times R2? 4 times R2 is 0, 8, minus 24, minus 4, 4, 0, and 6 times R3, 6 times R3 will be 0, 0, minus 24, 6, 6, 6. Just subtract this 0, 8, 0, minus 10, minus 2, and then minus 6. Okay. That is what is written. Now, after these operations, our matrix now becomes A comma B is becoming 4, 4, 0, 7, 3, 3. So, substituting the values 8, 0, 8, 0, minus 10, minus 2, minus 6, 0, 0, minus 4, 1, 1, 1. Now, we can see these two elements are made 0. The next job is to make this 4 0 by doing the operations only with R2. Okay, and this can be done with 2 times R1. So, new R1 is 2 times R1 subtract R2. So, what is 2 times R1? You can see 2 times R1 is 8, 8, 0, 14, 6, 6, and R2 is 0, 8, 0, and minus 10, minus 2, minus 6. Just subtract, isn't it? 2 times R1 minus R2 gives you 8, 0, 0, 24, 8, and this has become 0, right? 8, 0, 0, 24, 8, 12. Okay. So, our A comma B becomes 4, 8, 0, 0, 24, 8, 12, and R2 and R3 are written as it is. What is R2? R2 and R3 is written as it is, that is 0, 8, 0, minus 10, minus 2, minus 6, 0, 0, minus 4, and then 1, 1, 1. Okay. Now, make this all the diagonal elements as 1 so that it becomes a identity matrix. So, R1 is equivalent to R1 by 8, and R2 is equivalent to R2 by 8, and R3 is equivalent to R3 by minus 4. So, this becomes 1, 0, 0, 3, 1, 12 by 8, 8, and 0 1 0 minus 10 by 8 minus 1 by 4 minus 6 by 8. Okay. And then this becomes 0, you have to divide it by minus 4. So, 0 0 1 minus 1 by 4 minus 1 by 4 minus 1 by 4. So, your A has become identity matrix and this required one is the A inverse. And this has become identity matrix. So, you can see the answer is 3 1 1.5 minus 1.25 minus 0.25 minus 0.75 minus 0.25 minus 0.25 minus 0.25 is the ultimate A inverse. A inverse is equal to 3 1 1.5 minus 1.25 minus 0.25 minus 0.75 and minus 0.25 minus 0.25 minus 0.25 is the ultimate A inverse, and you can verify this answer by checking A into A inverse is I. Okay. So, A is the given matrix 1 1 3 1 3 minus 1 minus 2 minus 4 minus 4, and A inverse is the matrix just obtained. If you multiply, we get the I matrix. Okay. I is 1 0 0 0 1 0 0 0 1. When A inverse is equal to I is satisfied, whatever the A inverse we have found is correct. Then after solving the linear system of equations by matrix method and finding the inverse of the matrix, now let us solve the linear system of equations by indirect method. This indirect method is also called as Gauss-Seidel method. Now, for Gauss-Seidel method, we have to check whether the given matrix is diagonally dominant, because here we cannot rearrange the matrix like we have done in a Gauss-Elimination method. For example, in Gauss-Elimination method, if any of the pivot element is 0, we can rearrange the equations in such a way that the pivot elements A11, A22, A33 are not 0. But in Gauss-Seidel method, we have to see that the given matrix is diagonally dominant. Diagonally dominant means all the diagonal elements are greater than the remaining elements of that particular row. This is the condition for diagonally dominant. Modulus of A11 is greater than modulus of A12 plus A13, and A22 is greater than A21 plus A23, and A33 is greater than modulus of A13 plus A33. After verifying the system of equations is diagonally dominant, let the given system of equations be A11x plus A12y plus A13z is equal to B1. Like that, first of all, if it is diagonally dominant, find out x from the first equation. That is, x is equal to 1 divided by A11. That is, you have to keep A11x on left hand side and take all the elements to the right hand side. So, x is equal to B1 minus A12y minus A13z divided by A11. From the second equation, you have to find out y. These are the initial values of x, y, z. Y is found out from the second equation, B2 minus A21x minus A23z divided by A22, and z is written as an expression from the third equation. Third equation, z is equal to B3 is minus A31x minus A32y divided by A33. So, in step 3, what we are doing is first of all put for the initial values, for the first initial values, you have to put y is equal to 0, z is equal to 0 respectively. First put y is equal to 0, z is equal to 0 in the first equation. So, x is equal to B1 by A11. Okay. Then for the second equation, put z is equal to 0 and x is equal to B1 by A11 to find y. So, B2 minus A21 into B1 by A11 divided by A22. Okay. For the third equation, to obtain the value of z, whatever the values you have obtained as x and y previously, that should be substituted. This is y1, okay, and this is x1, so that we get z is equal to B3 minus A31 into x1 minus A32 into y1, the whole thing divided by A33. Okay, this is our z1. So, we have obtained the values of x1, y1, z1 in the first iteration values. For the second iteration x2, you have to put the values of y1 and z1. For obtaining value of y2, put x2 and z1. For obtaining the value of z2, put x2, y2. Likewise, we have to substitute. So, for third iteration values, for finding x3, put y2 and z2, that is second iteration values. For finding y3, you have to put the fresh x value x3 z2. For finding z3, put x3 y3 values, that is as and when the values are found out, it is immediately substituted to find the next values. So, the iterations are continued till two consecutive set of values are same corrected to the given specified decimal places. For example, if our fourth and fifth iteration values of x, y, z are similar corrected to 4 decimal places, then we stop the iteration at 5 and say that the ultimate x, y, z values are the fifth iteration values. In this session, we were discussing about how to solve a linear system of equations. Direct methods and indirect methods were discussed. First of all, direct method means matrix method called Gauss-Elimination method was discussed along with its procedure and an example to solve the linear system of equations. Also, the procedure to solve linear system of equation by indirect method, also called iterative method or Gauss-Seidel method, was discussed. An example was worked out in solving the linear system of equation by matrix method, that is Gauss-Elimination method, and also the inverse of the matrix was found out using the modification of Gauss-Elimination method called Gauss-Jordan method. Based on the discussion in this session, the following question may be posed. Using Gauss-Elimination method, solve 3.15x minus 1.96y plus 3.85z is equal to 12.95, and 2.13x plus 5.12y minus 2.89z is equal to minus 8.61, and 5.92x plus 3.05y plus 2.15z is equal to 6.88. Thank you.